So cylindrical coordinate system means you have r, theta, and z. The z coordinate doesn't change. It's just that instead of x and y, you need r and theta. So you should always remember that there are these conversion formulas. R is equal to square root of x squared plus y squared, and theta is equal to tan inverse of y over x plus something added in case of different quadrants, and then you have x equals to r cosine theta, y equals to r sine theta. So you have to keep that in mind. It's a triple integral, so remember that you're going in the z direction. So there's a z direction, and then once it's integrated out, then there's the domain at the bottom. And often it's helpful to ignore the z and just look at what happens if you integrate the z coordinates. What is this part? So let's just look at what this is. Since this one is dy dx, this is really equals to y, right? Y equals to 0. So let's think about what this is. Y equals to square root of 4 minus x squared. What's that? Well, if you don't recognize this, you can square both sides. Add x squared both sides, and you get x squared plus y squared equals to 4. What's that?
Circle.
It's circle of radius 2. Now, does this give you the full circle? The answer is no. Why?
The center.
Square roots only produce positives, right? So what portion of the circle does this one give you?
Top half.
Top half. Okay. So this one is going to give you the top half of the circle. Y equals to 0 is, y equals to any number means it's a horizontal line, so y equal to 0 is the x-axis. So you start from here, you end here. You start from here, you end. Now, however, you should also notice that x is only going from -2 to 0. Okay, we know that this circle is radius 2, so it goes from -2 to +2. And we're only taking this portion. You see that? The circle is only taking from -2 to 0. That's where the x goes from. Is that good? So here's what we have. We have x from -2 to 0, and on here, we go from 0 until the top half of the circle. We're doing this. We're painting it like this. So this is the domain on the xy plane. Do you agree? Yeah. Well, would you be able to figure this out? That's the hard part, okay? All right, so now let's include the z. See, z coordinate is coming out from the board, right? And then z equals to 0 is just the xy plane itself. But then z equal to x squared plus y squared, what's that? Do you remember the shape of z equal to x squared plus y squared? This is
It's a bowl.
it's like a bowl, right? It's a parabolic bowl. It's a called paraboloid, which is in 3D shape. It's like this, where this is the origin. So in this picture, what's happening is you have something like that. Okay. Now, however, when it comes to switching to cylindrical coordinate systems, the dz part is not that hard because z doesn't change. It's really the challenge is going from xy to r theta, okay? So we can pretty much leave the inside unchanged except, see, x and y are not allowed, right? We have to change to r and theta, right? So what should we replace x squared y squared by?
R squared cos squared theta plus.
Okay, so one way to do it would be to say
squared.
x squared plus y squared. Since x is r cosine theta, this is going to be r squared cosine squared theta, and y is r sine theta. Y squared is going to be r squared sine squared theta. And then if you factor the r squared out, you get cosine squared theta plus sine squared theta, which is equal to 1, and you get r squared. Okay. You can do that, or you can just simply see this as, hey, r is square root of x squared plus y squared. So if you square both sides, r squared is x squared plus y squared. That's faster, right? Yeah. So either way, if you see it, then perfect. You can just replace it like that. If you don't see it, then you can just use this formula to switch things on. Okay. So this is where we are at so far. Okay. We have, I don't know what to put here, right? What to put here. But the x squared plus y squared can be replaced by r squared. And z equal to 0 is 0, that doesn't change, but this x squared plus y squared can be replaced by r squared. Oh, by the way, if you're, I think I skipped this part. So if you want to know what we are integrating, the integration domain is really the bowl shape above here, right? And this bowl shape, so it's like under the bowl above this area. That's where we are integrating. Okay? And this will be like a density function. So you have certain density function, the mass of that object would be this interval. Okay? It's a very complicated one. The purpose of this problem is whether you understand how to read triple integrals and successfully convert to other coordinate systems. So the value of the integral itself is not so important. That's why I wrote down do not evaluate the integral. You may see those kind of questions on the exam as well. Okay. All right. So that's what we have, and then there's another thing. Dy dx. Oh, I should also write it somewhere here. Dy dx is same thing as r dr d theta. Okay. We've learned that before, right? So we're going to stick in r dr d theta. Now that we've handled the dz, which was like almost no work, all we had to do was just convert these into to polar coordinates. Now we have to somehow manage to paint this region in polar coordinate system. How do we do that? Well, in polar coordinate system, dr is inside, right? Dr means which direction are we doing the brushing?
From the origin.
From the origin, you're going external, right? From it's like that, right? And for us to paint this region, we have to do that. That's the way we are going to paint this region. You agree? Okay. So you begin from the origin. So r starts from 0. This point right here is r equals to 0. What is this one? R equals to?
Oh wait, no.
No.
Negative 2.
No, positive 2.
Positive 2?
Yeah, because
It's just distance.
So to explain that part, this point in polar coordinate system is really 2 comma pi.
Okay.
Yeah.
This.
Okay, so 2 comma pi in polar coordinate system is same as negative 2 comma 0. So if you go in the 0 angle direction, but 2 steps back, you're here, you landed here. 2 steps in the direction pi. Pi is 180 degrees, right? Yeah, so if you go into 180 degrees from the positive x-axis, 2 steps, then you land at the exact same point. But see, So you could make r go from 0 to -2, but then the angles get messed up because your angles will now vary over these directions. So it's much more complicated. So let's just keep r as 2. But now let's think about the angles. Angles go from where to where?
1/2 pi to pi.
Pi over 2 to pi, right? This is, in radians, this is pi over 2. This is pi. Remember that? 0, pi over 2 pi. This would be 3 pi over 2, that's 2 pi. Is that good? All right. So theta will be from pi over 2 to pi. Okay, good. So now we can put those in here. And when r goes from 0 to 2, and theta goes from pi over 2 to pi. Now, it's customary to just bring all the functions that are multiplied inside. Yeah. Although you can still calculate like this. It doesn't prohibit you from just calculating this. R squared is considered as a constant when you integrate by z. So this is perfectly doable in calculation. However, it's customary to bring these things that are multiplied inside. So the well simplified solution would be r cubed dz dr d theta. Okay, so that's the answer. Yeah, that's it. Yeah, I said do not evaluate the interval, so you don't have to